Hello students, how are you? I hope you all are well. So in my previous video I explained you the concept of energy, the concept of work and the formula that how we can calculate the amount of work. So in the previous video I had explained all these concepts. So now we move further. Okay, before moving further I have a suggestion for you. When you are watching this video, you have to use headphones for the better quality of the sound. So okay, now I am starting from the page number 44 of your book, page number 44. So I have written some important points here. These points I had just copied from the book. Okay, in my previous video I told you that 4 examples are given to you. Today I am going to discuss about that one from the page number 44. And the example is about a person who is wearing a helmet on the construction site, and another example is a girl, she is running. So I will explain these two examples, that why the examples are given to you and what is the relation of these examples with the concept work. So in the last video we had discussed that when we are applying a force on the object and the object displaces through some distance, in that case we can say that the work is done. If the object is not moving, in that means we are saying that the work is not done. If the object is not moving, it means the work is not done. Okay, today I am going to explain a very interesting thing, and the whole concept of this chapter is based on this thing that I am going to explain you. So last day we had done the energy and the concept of work. Today I will explain you that what is the relation between the work and energy and what is exactly the practical meaning of all these things. So listen carefully and watch this video carefully. So take an example. When we are applying a force on the object, as I taken the example of the chair, if I am applying a force on the chair starts moving. Moreover, we can take another example, the best example of the bicycle. It is also given in your book. A boy is riding a bicycle. So when the boy is starting doing efforts on the pedals of the bicycle, what will be the result? Of course, the bicycle starts moving in the forward direction. So it means when the boy is applying the force, the object starts displacing. So in this case, the work is done. If the boy is continuously applying efforts on the bicycle, it's continuously moving. So it means when the boy is applying the force on the object displaces. So in this case, we can say that the work is done. Now we can think in another way. Just suppose if the boy is simply sitting on the bicycle and he is not spending his energy on the bicycle, can the bicycle move? Of course not. If we are not putting a petrol in the bike, can the bike work? Of course not. So it means whenever we want to do some work or we want to make the object do the work, then we always have to spend the energy. So the same thing has happened in the case of bicycle. A boy is paddling the bicycle, it means he is spending his energy on the bicycle, and in result the bicycle moves in the forward direction. So basically the relation is whenever we are spending the energy, only in that case the work is done. If we are not spending any energy, then the work can never be done. Same case, you can take any example. When I started the video, that time I had taken the example of the fan also. If the electricity is not available at the home, then the fan will not work. Means if we are not supplying the electricity to the fan, then the fan will not work. So basically we have to spend the energy on the fan through the electricity, and only in that case the fan can work. So basically when we are doing the work or we want to make the object to do the work, in that case we have to spend some sort of energy. So that is why I have written here, energy spent is equal to the work done. Means when we are doing any work, that time we have to spend the energy. Clear? So that is why an example is given to you of a girl. She is running. Running means she is spending her energy, and that is why she is moving in the forward direction. means she is doing work when she is running. So that is why her energy is spent on this work. So that is why this point is came out from the explanation. Energy may be spent when an object is made to work. Means when we are making the object to do the work, that time we have to spend the energy. So okay, I hope this first point is clear to you. Whenever we are doing any work or we want to make the object to do the work, we have to spend some sort of energy. Okay, now let's think on the other side. Means I am doing a work on the object and I am spending the energy on the object. It means my energy lost in doing that work. But the object on which I am doing the work, object's energy increases. How? Take an example again, the same example of the bicycle. Suppose I am riding a bicycle and I am spending 10 joule of energy on the pedal. It means I am spending the energy, my energy getting lost in doing this work, but the bike or the bicycle starts moving in forward direction. Why the bicycle starts moving in forward direction? From where the bicycle is gaining this energy? Of course, the energy which I am spending on the bicycle, exactly that is equal to the energy the bicycle gains. So, in simple words, I am spending 10 joule of energy on the bicycle and the bicycle gets this 10 joule of energy from me and it starts doing work. Work means it starts moving in the forward direction. So, basically it is only a energy conversion. So this is also called the law of conservation of energy. We will also discuss this one later on. It is also in your syllabus. So just understand my point. Whenever we are doing the work on the object, it means we are spending the energy on the object. Our energy lost in doing that work, but the object on which the work we are doing, the object's energy increases. And how much the energy of the object increases, that is exactly equal to the work done which are done by us. Is it clear to all of you, I think now? So that is why our second point is an object in motion has an amount of energy. It means when the object starts moving or the object is in a motion has an amount of energy equal to the work done on it. Means how much work we have done on the object, that is exactly equal to the energy of the moving object. Of course, when we are doing a work, the object starts moving and if I am spending 10 joule of energy, then the object gains this 10 joule of energy and it uses it to make the object to move itself. So I hope this point is also clear to you. That is why the first example is given to you of a person who is wearing a helmet on his head on the construction site. Because of we know that so many heavy things are placed on some certain heights on the construction site or in the construction building. And if somehow we know that Earth always applying a gravitational pull on each and every object, and the object which is placed at a height can fall on the persons. So when the Earth is applying the force, it means force is applied on the object and object starts displacing in the downward direction. It means the Earth do the work with the help of gravitational pull on the object, and when the Earth do the work on the object, it gains the energy and it starts moving with the kinetic energy. Of course, we know that the objects which are in the motion, they are always called in the form of kinetic energy. So that is why with the help of this kinetic energy, the object starts moving in the downward direction, or it can hit the person and can cause a severe damage to the person. That's why to avoid these kind of accidents, the person is wearing the helmets on the construction sites. So that is like 2 examples are given to you. So okay, now the next concept in your book is work energy theorem. This is on page number 45. So 2 examples are also given to you. A boy is riding a bicycle and a cricketer is hitting a ball with a bat. So later on you will understand these 2 examples also, that why they are given here. But before explaining the examples, I want to tell you that what is the work energy theorem. So basically you have to understand now the only basic things, and you will be learn about this one in detail in your next higher classes. So what is the work energy theorem? So as I already told you, when we are applying a force on the object, it starts moving. Then it gains a kinetic energy. From where it is gaining that kinetic energy, that is exactly equal to the work done that we are doing on the object. Suppose I am pushing a car. Just suppose I am able to push a car, and when I am pushing a car, then the car starts moving in the forward direction. It means the car gains a kinetic energy that is exactly equal to the efforts which I am doing on the car. I am spending 10 joule of energy on the car, and with the help of this 10 joule of energy, car starts moving in the forward direction, and then the car has a kinetic energy. That kinetic energy is equal to the 10 joule. Just suppose now this is an example. Clear? So basically, when the object is already in motion, I am pushing a car. Clear? With 10 joule of energy, and one friend came to me and told me that I will also help you, and we both start pushing. It means the car is already in motion and we are applying more efforts on the car. In the result, what will happen? The speed of the car will increase. Means, why the speed of the car increases? Because the kinetic energy of the car increases. And from where the kinetic energy now car is gaining? Now we both are applying the efforts on the car. It means when the object is already in motion, if its energy changes means its energy can be increased or decreased. So we are just taking an example that the energy is increasing. So when we are applying a force on the object and the object is already in motion, and if the energy of the object changes, it increases, then that increased energy is equal to the work done by the forces on the object. Means the extra work done that is done by my friend is be resulted as a change in energy of the car. So the kinetic energy of the car is increased. So with the help of example you can understand, and then I will read this definition that is exactly in your book is given. Okay, now suppose I am pushing a car from here. I am spending 10 joule of energy and it starts moving in the forward direction. It means how much energy this car has, that is equal to 10 joule, which the work I am doing here, that is exactly equal to the force that I am applying here. So here my friend also joined me and we both start moving, pushing the car, and he also spent 10 joule of energy on the car, and the total amount of energy that now car has is equal to 20 joule. It means its 20 joule energy increases. Why? Because extra forces, extra efforts are now doing by my friend on the car. It means change in the energy due to the motion of an object. When the energy changes of the object which is already in motion, that is exactly equal to the work done by all the forces on the object. That is exactly equal to the work done by all the forces on the object. Now my friend is doing the work on the car. He is spending his energy, he is applying the force on the car. So it means the object which is already in motion, if its energy increases, it means how much energy it increases, that is exactly equal to the work done that we are doing on the object. So this is the work energy theorem. Is it clear now? So the two examples are given to you in your book. A boy is riding a bicycle. When he starts applying a force on it, when he starts spending energy on it, the kinetic energy of the bicycle increases. How much the kinetic energy of the bicycle increases, that is exactly equal to the work done by the forces which has been applied by the boy. So the same example of the cricketer also. A player is playing in cricket, and when the ball is moving towards him, he hit the ball with the bat. Means he is applying a force on the bat, on the ball. He is doing the work on the ball. In result, the kinetic energy of the ball increases. How much the kinetic energy increases? How much the kinetic energy of the ball increases? That is exactly equal to the work done by the player on the ball. So that is why all these two examples are related to the work energy theory. So now the next concept is 1 joule of work. How we can say that we are doing a 1 joule of work? When 1 Newton force is applying on the object and the object displaces only a 1 meter of distance, in that case we can say that this 1 joule of work is done here. So work of 1 joule is said to be done when a force of 1 Newton moves an object through a distance of 1 meter in the direction of the force. I had also explained in the example. So I am applying a force of 1 Newton on an object and the object displaces. S stands for the distance. Only of 1 meter the object is displacing. Then we are putting the values in the formula displacement. So force is 1 Newton and displacement is 1 meter. 1 into 1 is 1. So it will become 1 Newton meter. You can also write it as joule. So basically now you understand that the work done and the energy both are same thing. So that is why their units are also same. Both are the form of energies. So that is why their unit is joule. So there are different units as given in your book to define the energy, as we are define the distance in kilometers, in meters, in centimeters, like this also. So like the same way 1 kilo calorie contains 1000 calories and 1 calorie contains 4.2 joule. So this is your topic. So I think this much is enough for all of you for this first lecture, and in the next lecture we will discuss about the different forms of energy. So till then you have to prepare this one. Okay, thank you. And if you still have any doubt, then you can also contact me. You have my contact number also. So thank you.